normal construction, it won't move until you reach, suppose the clay is subject to 600 kilopascal in the past, until you apply 600 it won't react. So that's where these pressure distributions are idealized to give you what is the pressure distribution at the back of the wall, how we can calculate. So this is something that you got to look into and say, right, if I know it's a London clay, type A, that is the wall, that is why you apply this kind of distribution. And if you got another type of soil, class B, is a stiff to very stiff clay. So most of the London clay, this is another thing that you're going to look at, is going to be a small exercise I told you. If it is a stiff clay, simply you apply 0.3 gamma H. So that means if you are digging 20 meter basement, 20 meters times gamma is the density, 0.3. Yeah? So we talk about 120 kilopascals of pressure at the base as a rectangle. So that 100 kilopascal represents roughly about 15 meters of dig. So that's the stiff clay. And that is how we use again B, soft wall and a stiff wall. Yeah? Any questions? And then if you got again class C type of soil, which are granular soils, again 0.2 gamma H, because these things are again based on the observations, idealized pressure distributions for a quick preliminary design. And obviously water is whatever is the water. Water you cannot, there is no. So if the water is standing up there, it's gamma H, including that. Yeah? If it is dry, obviously that triangular hydrostatic pressure distribution is zero. So in terms of, so we know the loads now. We can calculate roughly, depending upon the type of the soil, we know what the ideal pressure distribution at the back of the wall is. So once you know the pressure distribution I have drawn with the prop spacing, now we want to calculate what the prop loads are. How do we design the prop load? So this is actually about, so before I go for that, I just want to show you a video in terms of the So this is a site in London where you can see a top-down construction is used to get a benefit on the program. I think it's almost about a year benefit in the program. So this is the, again, you can see all the continuous pile going there. We're talking about that being a 50 meters, the site is about 100 meters long. That's the plan view of the site. So we've done all the piling for the building from the ground level. We are digging now bit by bit. We put a logistic deck here for the plant movement because that's a busy road. And then you can see here we created a top deck now.
This is bin.
Yeah. So the beauty of that is we are dropping, these are all the plunge columns. As we go down, we are exposing one by one. Can you see that? So we're going 6 levels. While that is on the top, we're building finishes on those hotel buildings. So before you reach, so you can see 1, 2, 3, 4 levels of basement, we've already built 10 floors above the ground.
So is this what you have by a hybrid system?
Well, this is fully top down.
Okay.
Yeah. Yeah, you could say, because although this is top down, that is still, you could say bottom up. But what I meant by hybrid is, in some cases we use, within the same site, we use partially top down, and partially bottom up. With reference to the basement, I'm referring. Yeah. So that is how we do a top down construction. The beauty of that, yeah. Two different levels.
Near the first floor. Construction.
Oh yeah, because there are 3 buildings here. The floor levels don't match. That's all, because some of them are car parks. So there's a reduced floor height. So you look at the floor levels don't match. Is that what you mean?
Yeah, why not design it?
That is because the client wanted to keep car park in certain areas, plant in certain areas. So the height of the building changes. In a car park, you need only 2.5 meters. If you are putting a plant, you need about 4 meters. So the heights are not matching. So because it's a very large footprint, that footprint, I think you can see,
Getting more cost with the
it's like that. So that area is car park. This is where there's a big transformer, and these are all plants.
going here.
So this whole site is divided into 3 buildings. It's 100 meters, I told you.
We are going
So that's building 2, building 3, building 1. So the floor levels are not exactly the same level as we dig it down.
What would you use the steel pipes for? What would you use?
You will not concrete.
Why would you use the steel pipes?
Instead of the steel plunge column. Yeah, very good question. I think what happens with the concrete is we have a big bow which is big casing, right? The casing is filled with what is called lots of shingles because the gap has to be filled up. Steel will go in there with a template and sit in there. The area is filled up with the lean concrete. We have to go down and break it. If you use a concrete, remember the client wants to see the same finish. If you are using a precast one, we have to use this, they need to see the same finish. So there's a lean concrete around that concrete. We've got to break it. So that is where I think the problems will come in terms of how do you actually make sure your precast concrete column that is nicely dropped into the hole has got the same finish as you start digging. Because remember, in the hole there's a lot of other stuff that we have to put. Not only shingles, but a bit of a lean concrete. Because the whole casing has to be filled up at the end. Otherwise it will start, moving. Because the whole thing is moving. So we prefer to use the steel column because once you start breaking this lean concrete, it's easy, and you can see the connections. But then also, with the concrete, what happens is you are also limited by the height. In the plunge columns, you bring a plunge column, you splice it, you push it down. So that exercise I told you, we're talking about plunge columns of 15 meters. So you bring them normally 7.5 meters, 8 meters, one splice you drop it down. In concrete, again, the connection becomes an issue. We've got to think of those connections. It is possible to do it, but I think precast piles we have used, but precast plunge columns, connections becomes a big issue. How do you actually connect 2 pieces in there before you drop into the hole? Yeah. So steel is much better to manage in terms of those connections. So this is the other one where we talked about the bottom up down. So that's the existing buildings demolished. You can see all the surrounding buildings. We are now dropping all the existing buildings. Now we're going down. We created the perimeter. Now exposed all the existing piles, existing foundations. So after the secant walls are done, we have put the props, cap and beam, props, corbels, and then we are going down, constructing from bottom up. Take a break for 5 minutes.